Hey all, welcome back. And you may notice that my picture is on the other side of the screen now, just because I was blocking the sidebar I was finding. So yeah, we're gonna look at how that ends up working. So what we want to do in this one is it's great what we have right now. We can select the X and the Y axis. However, so if you look at the clean data function, it's still hard coded to use the weight and the deadlift. So what I'm really looking to do in this video here is I'm looking to kind of give the user more control over the data cleaning process that they want to use. So they can choose whichever statistics they can edit the sample size that they want to use for the plot. They can set an upper and a lower bound, so we can say like 123 pounds here. That's the upper bound. Um, they can remove outliers beyond a certain standard deviation, so that you're not seeing as many outliers. So we also have the stats tab here, so you can actually see the distribution for what you're choosing here. So you can remove deviations that way, and so you can kind of see like what's happening in the graph here. Just because we set we'll set this back to 1000. So you'll see more of a bell curve shape on that now. So now you can start playing with the deviations a little bit more. We have that displaying here too. Alright, so enough of giving you an intro, so let's get into it. Alright, let's get to work here. So what we're going to do first is we're going to change the parameters on this function. So we want a sample size, and this is going to be an integer. And we want, what do we want here? We want the x-axis. And this is going to be, whoops, caps lock. It's going to be a string. The y-axis is also going to be a string. And I'll explain these more in a bit, but for right now, I'll just put them as parameter. The x thresholds so this is going to be a tuple, which I don't think we've used that much. And this tuple is just going to be ints, and then the y thresholds. And this is also going to be a tuple. So these tuples both of them are going to have an upper and a lower bound. So I'm going to use those to, instead of these numbers here, 500, 100, 1010, I'll use that. So the first thing that we can do, x-axis and y-axis. X-axis, x-axis, y-axis, y-axis. This will change to the sample size that we'll put in there. And so the way to access tuple fields is the first one on here is going to be the lower bound, and the second one on here is going to be the upper bound. You can pretty much almost get these just like a list. So we can say x thresholds, and this was, yeah, the upper bound. I'm trying to think. So that would be the first index. and then this would be the 0th index. So then y thresholds 1 and y thresholds 0. Okay, great. So what do we want to do next here? We want to actually go back to the main function. And the way that we're calling this right now is we have this here, so you know what, let's define what these are going to be first. So the sample size, what I'm thinking here is this is going to be another Streamlit feature. So we're displaying a set of radio buttons to the user. So the first parameter here, the label, will be, we'll just say select a sample size. That's fine. And then the second parameter is the option. So options equal, and this is an iterable, so we have to have this be a list. And we're just going to do 1,000, 10,000. I have to like count the zeros in my head. Okay. And so that's how we'll get that. So that'll be the sample size. The x and the y axis, we already have those defined. I actually want this whole thing to be in the sidebar. So we'll put this down here. And the actual cleaning function will go after here. That's fine. Okay. So now we've already defined the x-axis and the y-axis. So what we need then is we need the actual thresholds. So we're going to say x threshold lower equals st dot, so these number inputs, this is going to make it so that you can only input numbers, and you'll have like a little spinner feature off to the side. So we'll say we'll make this an f string since we want the x-axis string to be in here. And we'll say select lower bound for x-axis. And then so you can specify, when you're specifying a number input, you can say what the min and max are going to be, and then what the default value is going to be. So the default value is just going to be 0, and then what you want the step to be, which we're going to just set to 1. And just gonna copy this a few times. X threshold upper. Yeah, those are gonna stay the same. We'll have 1,000 for the default value that it is right now. So then and set that to the y-axis. And then so I said they were going to be tuple, so for x threshold, do that, and then just backspace over the part that we don't need. That's fine. So we want to use rounded brackets to specify this. So the first one is going to be the lower, and the second one is going to be the upper. The reason that we're using a tuple rather than a list is just a tuple is it's a little bit more efficient. They're immutable objects, so I mean these things don't really need to change. If you select a new value stream, that's just going to redefine them anyway. So y threshold upper, and then down here in the first of all, we want that to be the y-axis. X thresholds equals X threshold. Y thresholds equals Y threshold. Alright. Okay. So let's take a look at what we have. So I'll bring this over. Looks like you can still see the screen. Kind of, even with the sidebar. So let's just refresh this. So right now we've got 1,000 for the age. No one is in there just because the sample size is only 1,000. So let's switch that to 100,000. And then you see we have a couple outliers. We have 115 and 125-year-olds. So let's say the upper bound is 90. And beautiful. So yeah, it redefines the whole thing, and it looks like the oldest people are like later 50s. Alright, so lastly what I want to do here is I want to introduce putting in those tabs. So the way that we'll do that in Streamlit is we're going to have two tabs. We're going to have one for the scatter, and then we're going to have a stats tab. So we're going to, I'll explain it here in a sec. So it's just the command in Streamlit is just st.tabs, and that just takes in, we can just put in a list here for what you want it to actually display. So we'll say scatter and stats. So what we're stats. So what we're using here is we're using tuple unpacking, which is a feature in Python where this st.tabs, this returns a tuple of however many tabs that you specified. So in this case, we have two tabs that we're specifying, so we can directly just access those and feed them into variables. Just makes it a little bit cleaner. So the scatter tab is, this is just going to be what we have. So just like what we've done before with the sidebar up here, we're just going to use the with statement for this. Actually, we have a with statement down here too. So and then with the stats tab, so what I want to do, right now I'm just going to have it defined as pass, just because I'm going to define everything for that right now. So let's put this below generate scatter plot. So this is going to be another function. We'll just call it generate histogram, which is just going to return a plotly object. So it's going to take in the data frame again. So just pd.dataframe here. And yeah, we'll just follow the same structure. So we'll say px dot histogram, and then okay, the data frame is the first one here. And then so the x is this just going to be let me check my notes really quickly. Okay, I do have the column on here as well. So we'll just say column, and this will be a string value. And we'll say x equals the column. How else did we define this? So, end bins is, that's going to be like how big that you want each bar on the histogram to be. So we're going to set that to 50 right now. And then we're going to put a little opacity on this, so we'll say 0.7. And then the title of our histogram, this is just going to be another f string, and we're just going to say distribution of, whoops, curly braces, column, like that. And then just return the figure. Okay. And then so back in the main function where we passed before, first of all, yeah, okay, so when we're importing, we need to generate histogram. We need to import that function as well. So then in here, we're going to have two histograms. We're going to have one for the x and one for the y. So x histogram equals st dot, or no, wait, sorry, this is just going to be the function. So it'll take in the data frame and then whatever we put on the x-axis, and then the y histogram generate histogram df y-axis. Okay, so now we're just going to basically just have two charts here. And we're just going to have the x histogram. And then actually let me, so there are a couple more parameters which we can just show right now. So use container width is, this is going to use the actual streamlit container width rather than just the size of the chart in the plotlet, in the graphing library that it's in. And we can also, there's another parameter called theme, which by default this is set to the string literal streamlit. So this will just integrate the actual streamlit theme. And if you set it to none, it'll just use whatever the plotting library declares, which might be kind of nice. We'll take a look at that in here. You know what I can do is, since we have two, I can show what they'll look like, and then, well, I already know what my decision is going to be, but you can make your decision too. So let's grab that. Always rerun. Yeah, of course this is syntax error. On plot.py on line 43. Yes, here. Save that. Bring it back over. Okay. Actually, wait a minute. Ah, okay, I see. I just wasn't scrolled down far enough to see the stats. So this would having theme none would look like. So it's using the base plotly design library for it, and this is what the actual streamlit, if you integrated it with the streamlit theme, that's what that would look like. As far as in the code here, we really don't want this chart should be included in scatter tab right here. So we'll save that, bring it back over. Okay, cool. Now we have the proper distribution. So the reason for bringing in this histogram here is it just makes it easier to see. So the sample size, if you're at 1,000, it looks pretty evenly distributed. But if you go to 100,000, that just makes it easier to see that, like, there are a few out here. Let's see if I can hover over it. Yeah, count 1 in between the age of 125 and 129. So, based on knowing that, we can go ahead and set the age range to, we could even set it to like 120. Well, we'd still have that person at 115 in there, actually. So we could even set it to, let's do 112. And it would get rid of those two outliers there. So that is pretty much what I wanted to go through in this video. In the next one, I will we'll go over how to calculate the standard deviations on here, so we could remove outliers just using the standard deviations instead. So join me in that one.